beg her to say the opening prayers.
Yes, assalamu alaikum. Good evening, all.
Good evening.
I'm Rukaya Kare. It's nice meeting such a wonderful, is it class or a program? I've been wanting to have such, and I was able to get this opportunity this evening, and I tried to join. I'm so much grateful, and may Allah reward you abundantly.
Amen.
Yeah. So you said I should give the opening prayer?
Yes.
Okay. All right. So Allahumma salli ala Muhammad wa ala ali Muhammad wa sallaytu ala Ibrahim wa ala ali Ibrahim innaka Hamidum Majid. Allahumma barik ala Muhammad wa ala ali Muhammad barik ala Ibrahim wa ala ali Ibrahim innaka Hamidum Majid. Bismillah. Okay, I think we can start. Thank you.
You're welcome.
Thank you.
Thank you for the prayers.
Thank you, sir.
Yeah. All right. This evening, this night, we are going to try to explain the multivariate non-graphical exploratory data analysis under experimental design, such that whenever we see data analysis, we should be able to understand what the person is trying to do, and we'll be able to interpret the data or the results of the experiment. Okay, let me, something was blocking my screen. All right, multivariate non-graphical exploratory data analysis. So yesterday we talked about the quanta plots, and this is a typical example. This one is a quanta normal. I said when the one set of values, let's say data, either sample or population, is plotted against a normally distributed data, or normal distribution itself read from the table, it now becomes a quanta normal. So this set of data being plotted against an expected normal value. If you notice this data, let me try and zoom. If you notice that the data, the distribution, the line is not a straight line, it's curved. So it shows that it is not, they are not from the same distribution, which means either the observed value is from another distribution, while the expected normal value is from the normal distribution. So when you see something like this, you now know that both of them are from different or slightly different distributions. It might be a distribution close to normal, but it is not a proper normal distribution. Do you understand? So this is that QQ plot introduces us to exploratory data analysis that is not univariate. You can use this in bivariate. You know, in univariate, you can only plot it against a normal distributed data or a normal distribution read from the table. That is called univariate. But in bivariate or any other like multivariate, you might be given different samples or different populations, different samples from different population or different populations. So to check if they are from the same distribution, you can use this normal, this quarter plot. So you can just run the analysis on your computer. You don't need to go into the details of doing the calculations by hand. So whenever you see something like this in a data analysis, you should be able to understand it. So if the data gives a straight line, you know that they are from the same distribution. So if one of them is normal, which means both of them are normally distributed. If one of them is normal and the other, and it gives this distribution, know that the other is not normally distributed. I hope we understand to that point. So still under multivariate exploratory data analysis, there is what we call cross-tabulation. Cross-tabulation is oftentimes used to compare different samples given same parameters. Now you see this data. This is a typical data. So this data was gotten, it was a two-table data which had age group and sex. And the age group, we have the young, the middle, and the old. And under sex, we have the male and female. But in order to analyze this data properly, this example, the person decides that he wants to split them. He wants to split. So he now says, instead of keeping them in such a way that we know that the young is a different population, the middle aged is a different population, and the old are different population. He now decides that he wants to split all of them and group them under normally age group and sex, but cross them, not keeping them in their various population, splitting them into and mixing them into one population. I don't know if I'm able to explain that, but the point here is this. It gives a group called young of a female sex, separate from a group of young people of the male sex. Understand? The first one, this GW, is the subject ID. It has the young, which is female. It has a middle, which is female. It now has another young, which is male. It has another young, which is male. Sorry. It has, yes, a young, which is male, another young, which is male. Now has a middle, which is female, has a whole, which is female, old, which is female. So in this case, he has taken each of the item in that in the table and arranged them differently for explanation. So he can decide to represent this in pie chart or any other chart as a different set of populations. Let me see if we can get a table, initial table for this data. Now, this is how the initial table looked like. This was the sample data. They have the male, the female, the total, the young, the middle, the old. So this person decides that he wants to arrange it this way. He can also cross-tabulate it by arranging it in this other way. These things are not by calculation. I hope you understand. There are ways of presenting data. You want to explain it to somebody. You want somebody to see that this is what this analysis is about. So I hope we understand it. So these data are from 3 different populations: the young, the middle, and the old. So the person decides to split them female, male. So you can either present it as female that is young, separate from female that is middle, and female that is old. Or you do same with the male. So it's a basic bivariate non-graphical exploratory data analysis technique. So you see this one is bivariate because it involves 2 different populations. In this case, that it has the female and the male. But in this other side, you can say it is 3 populations by having the young population, the middle population, and the old. So it all depends on how the person wants to present it. The first one, the person splitted it into different populations, as much as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. In this other case, he represented it in 2 populations. So another form of presenting data in the multivariate is the categorical data presentation. Yes, this data that we just presented as male and female are categorical data. Young, middle, and old too is a categorical data. So in categorical data, there is always correlation analysis. So whenever you have such a table, if you are using statistical tools, sometimes it automatically generates correlation for you, but sometimes you can just ask for the correlation of the data. So it will tell you how the young that is a female correlates with the young that is a old. It will now tell you how it also correlates with the middle. And it also tells you, as in middle, that is a male, not female, how the female correlates with the male, or how the male correlates with the female. So correlation has to do with the degree of relationship. And let me use this typical example. If you notice in our culture, using the same data, even though this data did not tell us what was collected, let's use this data to assume that we want to find how marriages occurred in the last week, that a young female wedded, as in 2 young female wedded and 3 young male wedded, 2 middle female wedded and 1 middle male wedded, and 3 females who are old wedded and 0 male who were old wedded. It's just an example. I'm trying to use this data to make out an example. You can say people that went for checkup the last week. Understand? So I'm trying to do an explanation. So we can find the correlation between a young female and an older male, or a young female, a middle female, and a middle male. So the idea of correlation is that how many female is waiting, or how many females going for checkup as against how many males going for checkup. So the correlation will tell you the degree of relationship, such that if 3 males go for a checkup, how many females do you expect to go for a checkup at a particular time? So it gives a degree of relationship between this group and the other group. You can also find the degree of relationship between the young, middle, and the old. So the correlation will tell you if this one is higher, will this one become lower? If this one is lower, will it become higher? So the degree might be 0.1 point something. So the degree varies either between male and female, or young, middle, and old. I hope we understand. That is how correlation works. So it's either you find the correlation between the young, the middle, and the old, or you find the correlation between the male and the female. So that is how correlation in categorical data works. All right. So let's talk about correlation and covariance. Even though we may not dwell it, let me just do a kind of summary in case you see it in any data analysis. Correlation talks about the degree, and the degree can be 0 point something. Any degree that is 1 is absolute, which means both of them must occur at the same time. I hope you understand. So correlation most often has to be less than 1, might be 0 point something. So a correlation, when it gets to absolute, shows that both of them are very correlated, such that this one has to happen for this other one to happen. Like in our culture, it is a man that gets to marry a woman, understand? So the correlation is strong. So it can be said to be 1. The degree of correlation is very strong. So even if it's 0 0.9 something, it's a very strong correlation. That when somebody is getting married, the correlation is that the person and the male and female. I'm using an example. I'm not saying that correlation works in marriages. I'm just using an example that something that is close to that 1, 0 0.8, 0 0.9 is a very strong correlation. So some correlation is less than 0 0.5 down, like 0 0.01, 0 0.02. Those are weak correlation. It means both of them, as in their degree of relationship, is low. Whereas covariance, the difference between correlation and covariance has to do with, variance has to do with distance. There was a time I was explaining, okay, one class I explained variance, that variance has to do with the deviation from the mean. Deviation from the mean, that this deviation from the mean is a vector. A typical example is that if I want to take the age, all of us in this class, and take the mean value, if the mean value is 25, some of us are 30 or 30 plus or less than that. So the fact that this person is older or younger, the younger person is not a lesser human being than the older person. And the older person is not a more human being than the lesser person. So you cannot, so if it was lesser or more, it's a scalar quantity. Scalar quantity measures how something is more than the other one. But variance is not a scalar quantity. Variance tells you the displacement, the distance. But in this case, not distance is a scalar, but in this case, displacement. How is this person different, displaced from this other person? So it talks about direction. So it is a vector quantity. A vector quantity. So if both of us are attending the same class, if both of us are working in the same office, we have the same usefulness. You cannot be better than me. But the difference is that the difference is in our age. So now it becomes a vector. How are you displaced from the mean? So if the mean age, out of, let's say 20 people, the mean age is 25. How am I displaced from that mean age? Not that how am I more than the mean age or less than the mean age? Please, I want response. Do we understand now?
Yes, please.
Yes. So covariance in this case has to do with variance across two different samples or two different population. Like we were talking about male and female. If you want to find variance of a female, it will be between a female and a female. But once we cross to a male to find a variance, it becomes a covariance. Like we're talking about the young, the middle, and the old. If you are dealing with only the young, whether male or female, only young, and we want to find variance, that is a variance. But once we find variance across either the young or the middle, it becomes covariance, or young, middle, and old. It becomes covariance. Understand? So we deal with the displacement between this one and this one. So first of all, we must get which one is the middle, and how does these other ones, the different samples and population, displace from the middle? How are they displaced? To what direction are they going? So this is the interpretation of covariance. Covariance is related to correlation. They are similar, but they do different functions. So correlation tells you the degree of how close they are. Covariance tells you their displacement. So you can actually use correlation to measure covariance. When the correlation is strong, the covariance is very small. When the correlation is small, the covariance is very large. You understand? So, which means covariance and correlation are what we call reciprocals. As this one is increasing, this one is reducing. And as this one is reducing, this one is increasing. So when you are seeing an analysis and you notice that correlation and covariance are high or both of them are low, there's something wrong with that analysis. Something is wrong with that analysis. So if correlation is strong, that is 10 to 1, like 0.7, 0.8, 0.9, the covariance must be very low, must go towards 0.0 something, 0.1, 0.01, 0.02. If it is as I and let's say 0.7 or so, know that as I as a correlation, know that something is wrong somewhere with that analysis. So these are things you pick up whenever you see analysis, somebody doing analysis, you check this simple thing. The graphs will make the thing presentable, but a real real data analysis should be able to check things like this. You look at the figures, the correlation, the covariance. After you have seen the data presentation, you check the mean, you check the variance, you check the correlation. If the mean tends to 0, you know that that data is from a normal population. If the variance tends to, as in variance of a particular population, not different samples or different population, you check for each population first before you now check for their combination. So if for each population, if a particular population has its mean going towards 0, small, 0.01, you know that it is possible that is a normal distribution. Then that is an first assumption. Second assumption, you check its variance. If the variance is high, you know that you are certainly right, that it is from a normal population. The variance can be 0.9 or so. Then you check other samples, Then once all of them are put together and check how are they correlated. First of all, you might combine each of the samples with each other one. If they are from the same, if you notice that one tends to normal, you combine it with the other sample and see. If it gives you a straight line, know that the second one is also normal. If it does not give you a straight line or something close to a straight line, you say, oh, this one is not actually normal. It might be another distribution. Then you now see how correlated are they. So these are things you easily read whenever you pick up you can pick up anybody's project. And these are things you know. If the person actually, you check to know if the person actually knew what you or she was doing. Not the presentation of data only. These are issues in experimental design that we need to take note. So I think we have done something that we can explain. This is a covariance formula. So we won't go into much calculation, but they did something here and they did the covariance and the correlation. So now we also have graphical presentation of data in multivariate analysis, which we have the scatter plots. The scatter plots, since you are plotting different data, you can plot y against x, y against x, and you can plot against z in the case of working with data that are three-dimensional, that requires principal component analysis. I know you will hear that in the future. So you have scatter plots. So these scatter plots will give you an example of how the data are being displaced. When we talk about covariance and variance, how displaced are the data? The scatter plots will tell you. So if it is very scattered, okay, we talked about box plots. Okay, let me explain the scatter plots. The scatter plot always have dots.
You cannot read and understand.
If I want to write it, so I can give my full mark. I don't want to write it for my play.
You are also teaching your baby girl now. Eh? All right. Scatter plots have dots all over. If the dots follow the same line, then we now know that okay, we've seen this message. We are going to excuse you. So we now know that it follows the same distribution. It also gives an idea of two data having the same distribution. So the scatter plot is a way of representing data. So from the scatter plot, we can know the displacement of each of the data points. So after scatter plots, we have the box plots. Now, each of these box plots represents different population. This is the one population, the other population, and the other population. So this box plot, I talked about box plots yesterday. Each box plot represents each population or each sample. So it has the minimum value, it has the first quarter, it has the middle value, it has the third quarter, and it has the highest value. That is 4 points. The one at the top is the highest value, then the third quarter, then the median, then the first quarter, and then the minimum value. In this particular example, they are testing strength of, I don't know what the data was, but let me see. I don't know what the data was either way, but I've seen they put age group here. So the population for people who were 21 to 42 years, we have their box plot. For a population of 42 who were 42 years to 62 years, they have their box plot. Then 62 years to 82 years, they have their box plot. There are three different populations. So the idea of the box plot is to tell you the minimum for that population, the first quarter of that population, the median of that population, the third quarter of that population, and the maximum value of that population. So a box plot summarizes a population or a sample. So each of these box plots summarizes the data. So when you obtain data of everybody that was between 21 to 42 years, you are able to summarize it with this box plot, telling you the minimum, the first quarter, the median, the third quarter, and the highest of that particular box plot. Then this other box plot of people who were 42 years to 62 years now summarizes the person with the lowest, the person with the first quarter, the median, the third quarter, and the highest. So each box plot summarizes a population. So that's okay. This is a scatter plot, a typical example of a scatter plot. If we notice this scatter plot, they tend to follow a particular line. So we can say they are of same distribution. You check, they are following the same line. They are not all that scattered. There are some scatter plots that are so scattered that you cannot see a pattern. So this gives an idea of what distribution. So if one of the population was normally distributed we can conclude that both populations are normally distributed. If one of them was a T distribution, we can conclude that both of them are from a T or follows. Let's not, because the conclusion is not always absolute. You can say it follows or it tends to. You can say it tends to a particular distribution because this other one tends to that distribution too, because they follow the same pattern. All right, so that is for exploratory data analysis and how to understand. I did an explanation on degrees of freedom the other time. I didn't know we will have it in this text. So we may not have to go in to discuss it again. So maybe next class, which will be next week, we are going to enter another topic. It won't be learning SPSS. It will not be. We are going to skip because the idea of this our data science is to learn Python and other um, programming languages like R. So if you can, SPSS is very simple. You can just check it up down. If you have it in your system, you can always use it to run analysis. But the idea of this our class was to understand data science using programming languages. So that is why we didn't go into calculations, because we believe we should use the programming languages to do the calculation. We should use the programming languages for the calculations. So we will skip this in our next class. So let me see the next topic we will handle. Let's see the next topic we are going to handle next week. Okay. You can see even the SPSS that is used in doing calculation here. You can see correlation. So in this case, the age has a correlation of 1, which is a very strong correlation. So age and response time, the correlation between age and response time is 0.28, and that's it, the correlation. So it has a low correlation. So which means there's a strong covariance between age and response time. So that's it. That's how to read. You read data. I think. Okay. Let's move to. Let me see. I'm looking for the next topic. Or should we? Let me ask, or let me not assume. Should we use this SPSS explanation to discuss most of the things that we have discussed so far? The results we have in these calculations. Let me sample.
Yes, sir.
Okay. Should we do that? That will be next class.
Yes, sir.
So we use this to do
Okay, sir.
explanation that we asked, because they've captured all the analysis we talked about. We won't go into
Okay, sir.
using SPSS, but I want us to use this to so that we'll be able to explain some of the things that we talked about and we can see how they work. Okay,
Okay.
that will be next class.
Okay.
All right, thank you for coming. I know it might look like we are slow, but it is better we understand how this thing works. It's good
Yes.
to know how to program, but you must have
Slow
an
and steady wins the race.
you must you must
Slow and steady
understand.
wins the race.
That's true. It's good to know how to program. We can learn Python, know how to use Python, but if you don't know what we are trying to solve, we'll always get stuck. So I think
But
that is always
good evening.
hello.
Can you hear me? Sorry, sir.
Yeah, I'm hearing you.
Okay. Thank you very much for the excellent lecture, sir. Thank you so much. Unfortunately, we have missed a lot of class because we travel somewhere, so we couldn't able to attend some of the lectures that people have done before. So, and we really interested about what you have done before. We actually we want to learn seriously. So I don't know how we are going to do it because we actually need that skill seriously. So I don't even have the Python in my computer. So
Okay.
I actually, what I have in my computer is only SPSS, and which is also interesting that I wanted to learn. I don't know anything about data analysis. All what we have taught in the school is just calculation on paper. We just use formula and this to do it. So we actually need to apply in the real this thing.
Okay. All right. Though we are saving videos, but I don't stop. I don't think we should be having issues because I believe we can always ask questions, stop and ask, and we can always re-explain
Okay, sir.
them over and over again. Because once we are able to get someone, because like we learned, we did some introduction to Python.
Okay.
In the future,
Eh,
once we get somebody that takes us Python, a data analysis using Python, or another person, there's somebody that told me that he knows how to use R. Even if it takes us a data analysis using R, the most important thing is understanding the interpretation of this analysis and what you are looking for, how to compare different data from different populations. Understand? So that's the point. So like you say,
yes.
you need to understand Python. I
Yes.
know that somebody in that group is advertising a, a Python class, but though I'll
Okay, sir.
still get somebody that will take us on data
Okay,
analysis using Python. But what we are
okay,
targeting
sir.
now, like we entered
Eh,
is statistics. So we are
yes.
doing experimental design. So what we are targeting
Okay.
is for us to understand how to interpret. You can pick a set of, you can pick somebody's project or thesis, ability to
Yes.
interpret what it's saying. That is what we are targeting because it is what is
For
going to help
example,
us to know what we are trying to solve.
yes.
Excuse me.
Yes.
Okay.
Excuse me, please. Can I quickly chip in something?
All right.
You see, Abdul, I think
Yes, I can.
we have recorded lessons on this platform. You
Okay.
usually send the link to the platform, so you can check YouTube for all the lessons that you have missed.
Okay. Okay. Okay.
Listen to it.
Okay. Okay. No problem.
Explanatory. He made it
Okay. Okay.
simple
Okay.
with his explanation.
Okay.
So maybe you should try and go through at least 2 lessons in a week. So
Okay.
anything that is not so clear, you come back to the class on weekend and ask question. So he can quickly go back to do justice to whatever the question may be. You're welcome back.
Okay.
Thank you.
Thank you very much. Thank you very much. I will do that. I will check the platform, then I will go through the YouTube and listen to the lectures as well. Thank you so much.
Welcome.
Yes, thank you very much.
All right.
Yes, sir. For example, like the lecture that we just finished now, we went to Gombe State to do some work. We in the hospital they now ask us like to determine the degree of association between the anemia and malaria. I think this is similar to what
Yeah,
you are.
that's correlation.
Yes, and we also we are just confused that they give us a lot of data. This is for malaria and this is for these things. So unfortunately, because we need to do is beyond. We cannot do calculation because they want us to use computer and calculate it. So
But you were able to use SPSS to do it.
okay, yes. But we don't know how to do it. That's the problem, sir. It's
Uh-huh.
only on the paper using formula. That's what we know. We don't know how to use. We have the computer, we have the SPS, but unfortunately, we don't know how to operate the software. That's the problem.
Ah, that is another thing entirely.
You don't know how
Yes,
to use SPSS?
yes. I don't.
Okay.
Are you, I'm sorry, are you a statistician or a ex information manager?
No, just like information man. I'm not. I know You know how our work it is.
Okay. What do
Yes.
you major?
Eh?
What was your major in school? As in,
Medical microbiology and infectious diseases.
okay, I understand now.
Yeah.
Okay.
Okay,
What
okay. You may not know how to use SPSS.
Yes.
SPSS
So
is general statistics software. In fact, anybody doing analysis should be able to use it. What you do, I don't know. You just ask in the group somebody that can guide you through SPSS. Because
okay.
I don't want to go into packages like that. My scope is strictly on how to interpret, how to
Okay.
read analysis. Like this one I'm showing on this screen. If somebody presents you something like this, you should be able to read it and explain it to a layman. This is
Mhm.
what this means.
Okay.
So, like when they were asked about degree of association, the
Mm,
person expected you to run an SPSS analysis to verify the mean,
mm,
the median, standardized mean, find out if the population is normally distributed, which should be
mm,
because it's obtained, it has a lot of data obtained from different populations. And the person, if it was male, female, you should be able to identify, have some, have a way to group the data such that relationships and find the correlation and the covariances. So, and that is it. So
okay.
you would need several tables and ability to read those tables. I think somebody has to show you how to use SPSS. So you can ask in the group that it's not
Okay. No.
difficult, something that somebody
Okay.
can even show you.
Okay. I will do that, sir. I will ask. I will do that.
So because what I will strictly do is how to explain, how to read,
Interpreting.
interpret the results.
That's
Okay.
excellent.
All right. You say the prayers. Let's close for today. Till next week.
Okay, thank you very much, sir.
Welcome.
Yeah, thank you so much.
And you say the prayers. I know you are of different faith, so you say the one that you know. I will all say amen.
Yes.
All right. Are you not? You are not getting me.
Sorry, are you talking with me, sir?
Yes. I said you say the prayers, and we
He
all
asked
say
you to pray.
Sorry.
He said you should pray.
Okay. No, no problem, sir. Just do it, sir. No problem. Go ahead and do it. Sorry, I not get you. Sorry, sir.
all right. No problem.
Just do it for us, sir.
Okay.
Thank you so much.
I will give thanks to God for once again giving us another opportunity together.
Mhm.
We ask for His wisdom and whatever we have learned, that you, Almighty God, make it profitable and add to whatever we have known already. And where we have made mistakes and have errors, that you should forgive us and guide us through, that we might know better next time. Thank you, Lord, for hearing our prayers. These are many more we pray. In the name of our dear Lord and Savior Jesus Christ. Amen. Thank you. Good night, everybody.
Amen.
Good night, everybody.
Amen.
Okay, good night. Thank you very much. Thank you.
Good night. Thank you.
Good night. Thank you very much. Hi. Thank you.
Mhm.
Good night.